Well, the report, first of all, strengthens our understanding of the climate science. The basic science that the Earth is warming, it's warming very fast, and that human emission of greenhouse gases are the main cause. But we move on very quickly to cover what I think is one of the most striking features of the report. That is, the predictions that scientists were making 2 decades ago are now becoming reality. They're becoming observations. We see this in many different parts of the climate. The air is warmed significantly. The ocean is warming. Sea levels are rising. We're losing ice. We're losing sea ice in the Arctic. The big polar ice sheets are starting to lose mass. And we see plants and animals around the world are moving, changing the timing of their flowering and their reproduction, all in sync with a warming world. So all these predictions are actually becoming observations. What matters, though, for humans often are extreme events. They're the things that hit us, that we feel the day in and day out aspects of climate that affect our weather. Now, one of the breakthroughs over the last 2 years that we highlight in this report is that scientists are now able to pinpoint some of the influences of climate change on extreme weather events. The Climate Commission followed up a major IPCC report in 2012 to contextualize this for Australians and what it means for our health, our well-being, our environment, and our economy. For example, our weather's becoming hotter. We're getting more heat waves. There are record hot temperatures. They're lasting longer. We're seeing more heavy rainfall events, particularly in the northern part of the country. In the populous southeast, the risk of fire danger weather has increased in many of the stations that record this. All of these risks are likely to increase in the future unless we can stabilize the climate. And I think the last part of the report is really the most important. We really connect the dots on what it takes to stabilize the climate and keep it to a manageable level so we can cope with the risks. And that's clear in the numbers. We know that to keep climate below a 2-degree temperature rise, there's only a certain amount of carbon dioxide we can emit from now into the future. We know we have to decarbonize the economy by mid-century. The numbers are clear. About 600 billion tons of CO2 can still be emitted. That sounds like a lot, but we've already emitted 400 billion tons in just the last 13 years. So that means the pressure's on to get on with the job. There is a very important outcome of this. That means these growing fossil fuel reserves are creating a huge bubble that we can't use. We can only burn about 20% of the known reserves to stay within our budget and to keep the climate at a manageable level. So I think this report for the first time connects all the dots, puts the science together clearly with the risks, and then very clearly what the challenge is ahead of us. Now, we don't cover it very much in the report, but there is some good news out there. People are actually starting to get it. Businesses are starting to move. Governments are starting to move. We actually even see the big countries, China and the USA, are moving. Australia is moving in a middle range of countries like the Europeans who are also moving. So we're getting going with it. We've got to start. But the bottom line of this report is we got to intensify. We have to do more, and we have to do it more quickly to get emissions down and stabilize the climate. 2 degrees is an important number for several reasons. First and foremost, we look at the risks for humans, for our health, for our infrastructure, and so on. And we see that these risks scale with the temperature rise. Risks of heat waves, flooding, heavy rainfall, coastal inundation, all goes up as temperature goes up. But it goes up more sharply beyond 2 degrees. We still see some impacts at 2. It's not entirely without consequences. Also, though, some of the big uncertainties in the climate system as a whole, things like tipping over a big ice sheet or changing ocean circulation very significantly or releasing a lot of methane from the frozen soils in the north. Most of these are not likely to happen below 2 degrees, but the risk of tipping one of these big elements of the system goes up quite dramatically above 2 degrees. So there's a good, solid body of evidence from immediate risks to long-term risk to the climate system that says we don't want to go above 2 degrees. And that's the target we really have to meet.